Exploring new frontiers challenges us to look at ourselves and our world in different ways. What we learn along the way helps us better understand the environment in which we exist. But the increasing complexity of modern life, with its demands on dwindling resources, requires an integrated view of social, economic, and environmental factors. On this frontier, geographic information systems are having a profound effect on how we look at the world. If you know what GIS is all about, you already agree. If GIS is new to you, you're in for an exciting surprise. GIS unites computerized mapping and database management so users can capture, display, and edit natural resource, environmental, and urban databases in ways that just weren't possible before. Automated processing of geographic data offers strategies to organizations for better planning and more informed decision-making. Who can use GIS? Maybe a better question is, who can't use GIS? Cities and counties, school districts and universities, utility companies and federal agencies are implementing this technology. GIS was pioneered by Environmental Systems Research Institute, or ESRI, in Redlands, California. ESRI provides products and services used by 2,000 organizations, ranging from local governments and small companies to foreign countries and global corporations. Services include software design and development, installation and support, database consulting, database automation, and application programming, all directed at helping users maximize their geoprocessing application. The design of a useful and efficient GIS begins with a very simple concept. That is, in a single geographic location, there are layers of map information, such as environmental data, including soil type, vegetation, or geology, or area data indicating political boundaries, school districts, or zoning classifications. Demographic data might include people in the cities or wildlife in the habitat. Information that is vital in planning how to best expand a city or to conserve a treasured forest. A GIS is a tool for accessing, integrating, and distributing large, spatially referenced sets of data in any number of applications. For example, cities and counties must maintain maps and records related to land parcels, districting, taxation, park planning, and wastewater management. Developers want to know where to build new homes based on zoning, availability of gas and electricity, and distance from schools and hospitals. Foresters need to plan timber harvests and replanting based on forest age, soil type, and projected yields. Utilities must locate new facilities based on customer locations. Police departments allocate resources based on where and when crimes occur. And oil companies select drilling locations based on geology, lease ownership, and other important factors. ESRI realizes that organizations acquire a GIS for a variety of reasons, so the system must be tailored to meet individual needs. This approach is built around several essential components, including procedures for operating and managing the system, a database of information, the hardware which it runs on, and the software which provides the tools for meaningful analysis. But the most important component of any GIS are the people who need and use the technology. They might be faced with the challenge of improving services at a time of shrinking budgets, or are looking to eliminate the inefficiency and costliness of an overburdened manual system. For example, managing tax rolls can be a time and cost-intensive operation. Volumes of parcel maps are cross-referenced with address lists, owners' names, lot sizes, and more. A change in a tax assessment on a single parcel is fairly easy to execute, but updates for every parcel in a neighborhood, city, or county might consume all the resources of a department. A GIS can pinpoint all the necessary data in a moment's worth of processing time. Likewise, a municipality might consider a zoning change for a particular piece of property. It must notify all the residents within a certain distance of the site of the proposed change. To locate the appropriate addresses by hand can take an inordinate amount of time and result in an inaccurate list. But with a GIS, the entire task, including mailing labels, is computerized. ESRI believes an essential ingredient for the success of any organization's GIS is the development of procedures for how the database will be designed, updated, and accessed. This is critical in a city government where there are between 200 and 300 separate and definable tasks involved in gathering, entering, and distributing geographic data. Everything from land use planning, issuing building permits, managing roads and traffic, routing vehicles, infrastructure management, and policy making. Although the activities are different between departments, they share a common jurisdiction. Problems surface in a manual system when data needed to execute these tasks is located within a single department, making access difficult. Conversely, if each department maintains its own data, it can mean duplicate effort and inconsistent files. A properly planned and implemented GIS can eliminate these problems. ESRI's professional staff provides consulting expertise so that users can create a GIS that provides consistent and rapid delivery of information for multiple applications within a shared database. The database design phase is crucial to effective utilization. Good database design includes evaluating what the data is, who will be using it, and what kind of results or products are needed. In designing a municipal database, for example, there may be several departments that essentially need the same base information. The system can be designed so that all groups draw from the same accurate and consistent source of information, which is then specialized by each department as needed. There is tremendous flexibility in system design due to an important trend in GIS technology, the rapid improvement in the performance of computer hardware coupled with decreasing costs. Systems can be configured around mini or mainframe platforms serving multiple online users, or designed for smaller group and individual users in workstation and PC environments. Considering the range and flexibility in selecting hardware components, ESRI is very careful in helping clients acquire appropriate system technology. A step-by-step process looks at how the system will be used. A system design is prepared complete with an implementation plan, and a variety of training and support programs are available for ongoing user support. When it comes to selecting a GIS software package, ESRI's ArcInfo product is unmatched in power and flexibility. It is currently used in over 1,000 different applications. What separates ArcInfo from all the rest is a topological data structure. Every map feature is related to those around it. This means that intelligent data is readily available, making analysis functions powerful and fast. This is just what several users discovered when they were faced with some challenging analysis problems. The City of Los Angeles was required by state law to review some 600,000 land parcels to resolve conflicts between zoning and land planning. They had a court-ordered deadline, and the results had to be absolutely accurate. The project couldn't have been done without ArcInfo. The effort resulted in a database which is very productive now for other applications within the city. Masato, a suburban community located 2 hours north of Tokyo, was faced with siting a new housing development. The housing had to maximize existing roads and city infrastructure. Planners used ArcInfo's overlay analysis capabilities to combine 6 different layers of data. The composite view confirmed the original objectives of the study, that development could be located close to existing roads, on low slopes, without impacting on the hydrology and sensitive land uses of the area. The Potlatch Corporation's database of timber holdings includes land ownership, land use, ridgelines, streams, and road layers. Overlaying roads with logging and ownership shows accessibility to areas where trees are ready to be harvested. A similar combination shows adjacency of activity between different landowners so that adverse effects on the watershed can be avoided. They can also apply conditions on the study area by simulating in the computer any thinning or fertilizing effects that may occur over the life of the trees. The rapid developments in GIS are changing the way some of our institutions function. changing the institutions themselves, and probably changing the way we think about our personal and public environments. A careful approach and informed decision-making are the first steps towards implementing this new technology.